plus 1. Okay, good. 3 more problems, 3 more minutes. Perfect. Number 7. Now I want you to find f if, I'm going to tell you what the second derivative is. The second derivative is 12x squared plus 6x minus 4. In other words, I'm telling you the rate of change of the rate of change, and I need you to find what the function is. Damn, Mr. Rose, it sounds like we would need to have 2 initial conditions. Well, here they are. F of 0 is 4, and f of 1 is 1 go.
What?
So if I have the formula for f double prime, then f prime must be an antiderivative of that. So I'm going to antidifferentiate 12x squared plus 6x minus 4. And when I do that, I get
4x cubed plus 3x squared minus 4x plus c.
Yeah, good. But then, of course, I can, oh no, I can't really plug anything in yet, right? So I just have to wait.
Yeah.
So,
You do it again.
so I'll just like write this here. Yeah, so now, if, no, I don't know anything about C just quite yet, because this is f of 0 and f of 1. This is f prime, right? But I do know that if f prime looks like this, well then I can just differentiate again, right? This is what you guys did? So what is f? Well, f must be an antiderivative of all that. And if I do that, I'm going to get x to the 4th plus x cubed minus 2x squared plus cx, right? Because the antiderivative of a constant is just going to be cx.
Plus d.
Plus like d or something. And then now I can plug in f of 0. When I plug in f of 0, I get, what do I get? 4. So I get 4, which means that d must be 4. And if d is 4, then what is f of 1? Well, f of 1 would be 1 plus 1 minus 2 plus c plus 4. And that has to be 1. So if I did that right, what does c have to be?
-3.
C has to be -3. And thus, the only function meeting these 2 initial conditions is this one. Minus 3x plus 1. All right, how do we feel about this? Good, 2 more problems. Now we're gonna move to speed, acceleration, velocity situation. So now I will give you the formula for the acceleration of some object. Claim at any particular time t, this object is accelerating at rate 6t plus 4 meters per second squared. I will also give you the initial velocity. The initial velocity is -6 meters per second, and the initial position is 9. From that, please reconstruct the position function. Good.
Wait, why can't we hear the announcement? Did you just like take out the
I know some other teachers that did that one. Alright. Apparently it happens a lot. I never tried. Alright, so can we just do this really fast? If this is the acceleration, then what is the velocity function? The velocity function must be some antiderivative of that acceleration function, yeah? And then what is that? You go up a thing, so it's like 3t squared plus 4t. Is that what you got? Did I do that right? Yeah, plus c. But then c has to be -6. And so the velocity function is actually 3t squared plus 4t minus 6. And if that's the velocity function, then to get the position function, right, since acceleration is defined to be the derivative of velocity, and velocity is defined to be the derivative of position, then position is an antiderivative of velocity. And so if we anti-differentiate this, we're going to get t cubed plus 2t squared minus 6t plus like d or something. But then what's d?
9.
9. Alright, I know I'm going really fast, but is this mostly like working? Shivani, you cool? Okay, last problem. This is going to freaking blow you away if you've never seen this before. Watch as in the last minute of class I rederive the entire first month of freshman physics. Tell. We are large objects. The most important force operating on us is gravity. And as we are basically living in some pathetic little sliver of the surface of the Earth, it is true that the acceleration due to gravity is basically constant. We have a name for that constant. We call it g. So, fact, the acceleration due to gravity of a large object in free fall is a constant. Since it is a constant, I can tell you what the velocity is. Well, what is the velocity? It's an antiderivative of, the velocity is an antiderivative of the acceleration. In other words, it's an antiderivative of g dt. And what do I get? gt plus c. Okay, now suppose I tell you that the initial velocity is, well, let's just call it v0. If the initial velocity is v0, then what is the formula? What must the formula for velocity be in general? gt plus v0, right? Because if you plug in 0, you get like, okay. So what is the general position function? Well, the position function in general must be an antiderivative of velocity. In other words, it must be an antiderivative of gt plus v0, where g and v0 are constants, right? So what happens when I anti-differentiate gt plus v0? Do it. Steven. 1/2 g t squared plus v0t, is that what you said? Yeah, plus some other constant. Let's call it like d or something. And then suppose I tell you that the initial position is just, well, let's just call it s0. If the initial position is s0, then this is like suddenly in like basically 3 lines of calculus. You guys seen this equation before? Yeah. Yeah, like over and over and over again a bajillion times. I don't know what kind of weird crap Schaefer used or Davis to prove that to you in freshman physics, but there it is. That is the equation for the position of an object at time t in free fall. It is simply 2 antiderivatives away from the fact that the acceleration is constant. Ethan, is that mind blown?
Not really, but
Ethan is getting the mind blown. All right, the rest of you go crouch in a fetal position in the hallway. Eventually make your way to Spanish class.
Yeah.
I will see you Monday.